Now, if we know that the mass of the object is 10 kilograms, the work done by the net force is 10,000 joules, then we know that the change in kinetic energy is 10,000 joules. Now, this is identical to the situation before, but in the situation before, we found our final velocities by using the fourth equation of uniformly accelerated motion. This time, we're going to find the final velocities, and we're going to get the same results. We're going to find the final velocities using just the energy information. Okay, so from the energy information, which we could have gotten from the given information of the mass, net force, and the displacement, we get the work done by the net force. That's the change in kinetic energy. Okay, now if our initial velocity is 15 meters per second, what then should be our final velocity? Well, 10 kilogram mass at 15 meters per second has a kinetic energy of 1125 joules. We found that earlier. The change in kinetic energy is equal to the final minus the initial kinetic energy. So if it's the final kinetic energy that we're trying to find, okay, how do we find that? Well, intuitively, we know that we find the final value of a quantity by adding the initial value to how much it changes. But we could also treat this as an equation, solve it for final kinetic energy. We would get the same thing. So the initial kinetic energy, if we start at 15 meters per second, is 1125 joules. The change in kinetic energy, which recall we got from the force and the displacement, was 10,000 joules. So the total is 11,125 joules. So 1/2 mv squared is 11,125 joules. We solve for v. We get v, and I should remember the plus or minus here. I didn't. And you should always remember that. Put the plus or minus in here. Okay. The final velocity is plus or minus then the square root of twice the kinetic energy divided by the mass. We write that out. And you're going to want to do the units. I didn't include the units here because we need to be a little brief, so as not to take up class time with something we already know how to do, and hopefully you do. We get the square root of 2225 meters squared per second squared, which gives us plus or minus about 47 meters per second. The same final velocity that we got when we calculated the acceleration, and then used that with the fourth equation to find the final velocity. Now the questions also ask if V0 is 0, what's VF? If V0 is 5 meters per second, what's VF? You would calculate it the same way. You're just going to have a different initial kinetic energy, lesser velocity, lesser initial kinetic energy, to add to the change in kinetic energy that's the same in every case because, again, the force and the displacement are identical in all of these situations. So you're going to get a smaller final kinetic energy, and when you calculate this, then you're going to have a smaller number here. You're going to get a little smaller velocity. And the velocity you get from this calculation should agree with the velocity that you got using the fourth equation of motion previously.